Welcome to the second season of Can I Get a Retake, the podcast where education gets innovative. I'm Michelle.
And I'm Michaela. Join us each month as we dive into the trends and technologies shaping the future of higher education.
Stay curious, stay inspired, and come learn with us from today's educator. Join us for a lively conversation with two distinguished biologists, Dr. Carlton Cooper and Dr. Benjamin Rohe. In this episode, we discuss methods, both traditional and eccentric, of generating enthusiasm and engagement in science classrooms. The doctors provide insight on how they've carefully crafted a peer-reviewed digital text that aligns with the interests of students, both majors and non-majors. Dr. Cooper is an assistant professor of biological sciences at the University of Delaware. He received his PhD in virology from Mississippi State University. Dr. Benjamin Rohe is a professor and program coordinator at Cecil College. He received his master's in cell biology and anatomy and his PhD in biology education from the University of Delaware. Together, they co-authored the GRL title, The Exciting World of Microbiology, which is a microcosm of the collaborative nature of the sciences. Tune in as we explore their partnership and how it led to a robust program that prepares students for a future in microbiology. We make this easy. First, thank you for joining us. And we're interested in learning about the beginning. How did you enter academia? What brought you to biology, microbiology, anatomy, etc.?
All right. I see Ben give me that smirk, so I guess I'll go first. So the beginning. So my name is Carlton Rodney Cooper, and I'm from King Street, South Carolina. So you probably hear a little bit of that Southern twang. And I went to Morehouse College, got my BS in biology. And at the time, I thought I wanted to be a doctor. But I soon learned by doing some internships at like Mahara University that being a doctor is not going to fit me. But once I learned about biomedical research, that really piqued my interest. So I was a MARC scholar at Morehouse College. MARC was a minority program for STEM. It stands for Minority Access to Research Careers. And then I did an undergraduate thesis in prostate cancer, and that got me really interested in research. But I wasn't ready to go for a PhD. So then I went on, got my Master of Clark-Atlanta in prostate cancer at Clark-Atlanta. Then I felt like, okay, now I think I can do a PhD. So I went to Mississippi State, where I got my PhD in virology and modern biochemistry. And that's why I did a lot of teaching, and I actually loved it, except I taught cell physiology. And I did a postdoc at University of Michigan, where I actually used viruses to help me study cancer. And UD was my first job interview, and I got it. And the first class they had me teach was micro, which I didn't want to teach originally. I'm like, I don't want to teach micro. I want to teach something a little more exciting. But as I began to learn micro at a very fundamental level, because I was doing it for research, I wasn't thinking about teaching it. It shifted my focus, and now I love teaching this class. This class has made me the teacher that I am today. And I've always wanted to write a textbook, and I saved that at Ben Answer to see how we got here.
A strangely similar path, but I was not from the South. So ended up at Wesley College for an undergraduate degree, and I knew I liked biology and understanding most of the natural sciences. I did initially have the same thoughts as Dr. Cooper and thought med school, had conversations, shadowed some people. The science side of things, the research, the understanding, pretty much everything. So I didn't feel like I just wanted to go towards medicine. I wanted to have a better understanding of molecular and chemistry and kind of everything else. And I thought in the middle of it that I might end up in a chemical engineering program. Being in Delaware, one of the major universities is the University of Delaware, and they have an amazing chemical engineering department. When I came out, I had a couple jobs lined up, and the one that I took was actually with the Fish and Wildlife Division of the Delaware Department of Natural Resources and Environmental Control. And I was outside in the summer I was walking marshes, taking vegetation survey, just basically recording what plants I was stepping on as I was making my way out to the water from like a main road. And the one day I decided to look for an inside science job was because I was an initial hire, they didn't want to invest too much money into me. They kind of looked at me as like a seasonal employee. So I was out on probably about a 95-degree day wearing some borrowed chest waders that were insulated because they were for winter, but they were the only thing that fit my feet. The senior employee I was with got the boat stuck in some mud. It was my job to push and pull us out of the mud while he sat there comfortably and drinking his water. And I thought, while I was near passing out there in the marsh, that air conditioning sounded good. So in a similar way, the University of Delaware at that time, it was just before Dr. Cooper showed up. I think actually you were probably like the third or fourth faculty hire they did after they had brought in a new department chair to revamp the University of Delaware with a greater research interest. So initially it was the Department of Biological Sciences was kind of a service education institution inside of the college. And so they needed a laboratory manager. So they brought me in, and through the years, I ended up going from a lab manager to a research associate. For a brief period of time, I stepped out of that role and got my master's degree in cell and organ systems. Even though a lot of my work was molecular in nature, I was playing geneticist. I was mutating the genome of bacteria and introducing mammalian genes into them, and then manipulating them to check to see what mutations led to which phenotypes or changes to the protein. And so got a pretty well-rounded experience there at the University of Delaware. After that, I got moved into managing a core facility where I learned a lot of equipment and essentially now just filling in my science even more with molecular and cellular techniques. And so, then finally I took that and started teaching classes at UD, and I was employed a little bit more as, I wasn't full faculty yet, but I was, what do they call it, like instructional staff. Because of that, my focus initially was mostly science for non-majors or incoming freshmen. I wasn't really teaching the higher level courses. So that kind of shaped the way that I taught and who I taught to. And then finally, I followed that up with a part-time evening doctorate degree, which is an interesting way to do it while being full-time employed. So that was the great part. It paid for it. The benefit from the University of Delaware paid tuition. So I walked away with a doctorate in education, where the focus was essentially science education. Wrapped all of this up into a career in education and was hired at Cecil College to teach anatomy and physiology. And they saw my background and linked it into, like, hey, how about, this stuff? How about we rekindle a program that had kind of stalled a little bit? And so that program is essentially biotechnology and biomanufacturing, which is, again, using microorganisms and a lot of advanced techniques to make therapeutics and proteins, and I'm having to learn a little bit of business as well through all of this.
Continuous education all of the time.
Yes. I'm currently in grade 33 or something.
Could you talk a little bit about what sort of inspired you to collaborate on the textbook that you created with us, and along with some other collaborators on the different chapters? How did you meet? How did you decide, we're going to write a textbook together?
Oh, so that was me. But to give you some context, Ben and I have a really good working relationship. Actually, we best friends. So we were friends first. He's one of the first person I met when I interviewed here in 2021, and then started working. And he's helped me with, particularly when he was going into getting this doctorate in education. I actually was his co-advisor. I was learning stuff that I never knew about teaching. People think that because you're a good researcher, that translates you being a good teacher, or you can give an outstanding research seminar. That means you can be a good teacher. They are two different things, two different skill sets. One, you're talking to an audience of experts and they understand the language and they're already excited and interested to be there. And the other, you got the begrudging student, like, I got to take this class because I'm trying to go to medical school and they don't want to be there. And you got to get them buzzed, excited, right? So Ben helped me develop my virology syllabus. I teach virology now. He helped me revamp my cancer biology course into a second writing course. He helped me develop my race and health course. And we just have a really good working relationship. We published 2 papers together on alternative therapy. Ben was actually the model. I should have brought that, you know. And so I've been talking about this, but our first attempt at writing a textbook was to deal with the social biology of racial health disparity, which is a class that I teach. I'm in 2 departments, biological science and Africana studies. So it came back around again, and I said, I never thought about writing a micro textbook, but I didn't want to do it the conventional way of writing a textbook, hard copy, and then you have to sell all that, and things change so fast in science that by the time the textbook is out for a year, there's new things.
Mm-hmm.
Corona.
Yeah.
Right.
Mm-hmm.
Okay. And so I like this platform. So Ben and I got into a discussion, and I said, well, I'm not doing this unless I have help. Ben is also more organized than I am. Yeah, he's more organized. He knows how. I'm not good at teaching non-majors. Ben is exceptionally good at teaching non-major science. So even though micro is at our department is geared toward majors, it's their first introduction to it. So we need to use a non-major slant to it, if you understand what I'm saying.
That's one question we had, is how do you balance the depth of content with the need to make it comprehensible to majors and non-majors?
That's a Dr. Rowe question.
A lot of it actually came from experience. So while I was teaching a lot of 100 level courses, which at the University of Delaware is either students taking science classes for interest or breadth coverage or general education, making sure that they tick all the boxes so they can graduate. And Dr. Cooper was teaching 300 and above. It basically came out of conversations that we had about, one, he realized that there was usually some gaps in knowledge coming from the students heading into an already 300 level class. And the interesting thing is the students that ended up in that microbiology class, I remember one time, this was her first semester on campus. She had tested out of like introductory biology, the course that was needed to be a prerequisite for 300. And she came and she sat down the first day in a classroom full of juniors and advanced information. It did not go well for her. And that basically led us to kind of review everything and figure out what do the students need to know, and where are the gaps? What are ways that they could end up in this class without having all the proper information? So a lot of it ended up being kind of seeing the missing information that they needed, and that's the introductory chapters in the textbook go all the way back to defining microbiology and making sure they understand the difference between small microorganisms and large organisms like ourselves, multicellular. So while that is in most microbiology textbooks that are, I don't know, let's say 600 pages or something like that, you don't have time to cover that in your large 300 level course. But Dr. Cooper made sure that it was there and they cover it, and he found time to teach it while also still making the way through the rest of the material. So what it required was boiling it down into essential material with enough introductory to get them to the point where they'll understand the rest of the 2/3 or 3/4 of the semester and be prepared to move on. So, and a lot of it also came from In my doctorate in education, we did take some sociology and learning sciences classes. So instead of, there's science education, and then there's the science of learning. And it's needing to have a mindset of knowing the frame set of the students, the age, past experiences, and being able to engage the students without automatically coming in and being the old term is the sage on the stage. You're not trying to perform in front of them. You're actually trying to get them involved in a conversation, ask them, and just kind of pry out of them, find out what they don't know without making them feel unprepared for the class or anything like that. So there's an art to teaching where you can grasp the student's place in it and move them along and get them to where they need to be by the end.
And that's why Ben wrote chapter 2, because eukaryotic biology is required, and that's the course he teaches prior to that. So Ben, along with Brad Liefeld, he was my TA from micro, and then he decided he wanted to go to medical school. He wanted to be involved in this because he was thinking about pursuing a career in education too. So what we did was Ben took all the stuff, so in one chapter, very basic brief of everything they should know or should have learned from this 207, and put it in chapter 2 in a condensed fashion. So it's a review for them.
Oh, and I'm going to highlight Dr. Cooper's teaching technique as well. Early on, when you found out that they were coming in without information, you would, I don't know necessarily want to call it fear technique or anything like that, but you basically would, what was it, within the first 2 weeks of a class?
The first week class, they would have a 207 final exam.
207 being the introductory biology. So it's like, hey, do you remember this material? Can you check it? And, you do need to study for this. And as a reminder, this is what you need to know. Did it, done it, passed the test. Remember that from, you may have missed 3 months over the summer, or you maybe took it a year ago. And so it was a quick check of the student's understanding before moving on.
Yep.
And again, with that information that gathered from missed questions, concepts out of that, fill the gaps, and then move on into the microbiology.
Yep.
There's a point in your foreword, Dr. Cooper, where you mentioned that you learned that lectures are the least effective way to convey scientific information, and that it sounds like this transformation has really impacted your students' learning experiences.
Absolutely. So I was going through a transition. So I was hired as a research faculty. So the way I used to teach class is like giving a scientific lecture. Escherichia E. coli is a bacteria that is gram negative, and it's found in our diet. That is, for a scientist, they don't need excitement. They are excited, but for students, it's like, wah, wah. Okay, and so I went up for tenure. It was not successful at that time, although I am promoted now. It just happened. And I realized that I was going to have to make a change. So the department chair sent me to this thing called the Summer Science Institute. It was at Harvard. And this regal professor, I said, oh, look at me, I'm at Harvard, I've arrived. But he gets up and he says, what is the least effective method of conveying, I just love the way you talk, information to your students? Well, this is pause. And I'm trying to think of writing this and that. And he goes, lecturing. So no one out there was surprised with that, but I was, because that's what we all do. And when I went to Morehouse, they lecture. Clark Atlanta, they lecture. And Mississippi State, my PhD, they lecture. So what are we supposed to do? He says the least effective way of communicating information. And he went through a series of things of what we can do to make class more engaging. And I came back, and he warned us. He said, now, some of you could go back to university and you're going to revamp your entire course at one time. Don't do that. Take it step by step. But I couldn't. I was all in. So I came back and I trashed my whole way of teaching. And my teaching evaluation just went poosh down. Yep. For like I'll say like 4 semesters, because I was rebuilding it. I was like, you know what? I can't be least effective. Now, you can be least effective, I'll tell the professor, but I can't. I am a professor who went to this conference for a week and they paid all this money, and that's all they kept talking about with active learning, this and that, and pair sharing, and how lecture was the least effective way. I can't come back and do the least effective after all that. So I trashed it, and it gradually my evaluation started going up to the point that I have a waiting list of students trying to get in my class. And basically what I do is I'll lecture a little bit and I'll pause. And then I'll try to bring in real life situations. Sometimes it can be quite controversial. Sometimes I just do crazy stuff. It has no relevance to the class. It just breaks up the monotony of me standing there going blah, 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 blah for 40 minutes, 55 minutes or an hour and 30 minutes. So I'll get on the table, do a little dance. I'll tell them to stand up. So students say, this is disorganized. And I say, well, if I see you doing this, I have to wake you up. And I understand because some of my students my class like the third class they had in the morning, or the last class in the fall I have in the afternoon. So yeah. And when I was Ben advisor for his science, his doctorate in science education, they knew this. This was old news to them. I'm like, well, why didn't anybody tell us? My mom is a teacher, and I was telling her, she said, honey, my mom was a typical Southern Black woman that's very religious. She said, honey, praise the Lord. Listen, we've been knowing that. Where you been? Didn't you get a PhD? I was like, yeah. But I didn't know. But Ben and they probably didn't know it. So that's how he helped me sort of retool my lectures and to try to, be a little more organized, even though I'm chaotic. So I think the word people say is I'm chaotic organization.
And how does your title fit into all of this, the exciting world of microbiology?
But as we were writing the textbook, and I'll talk to you later, but the co-author, I want people to bring a level of enthusiasm in there, and I want to capture that. So I want it to be exciting even when they're reading it. So that I'm presenting it, they can find it exciting. And I want to show them that no matter where you go, what you do, there's always micro. You can't avoid it. Nor should you. Or sometimes a dangerous one. But they are also, I try to deal with them, but they're good bacteria. They're good bacteria. And that leads me to where the future of the field is going. I'll come back to that later because both Ben and I have a good idea about that, which is the microbiome.
Trying to make a textbook exciting is difficult, but having taught for a while and used a couple different kinds of formats, initially just the fact that we've got this in a format that is digital and puts you in direct links to other third-party source material, but hopefully then you can also make quick current updates to it. You're not constantly just staring at some two-dimensional static images, bring up questions about real-world applications. Now, again, none of that is necessarily new into the textbook world, but when hopefully what we're trying to do is pull everything together into a format that makes it a little bit more engaging to use, and then paper copy that hurts your back as you drag it to class. Kind of like the same way that Dr. Cooper teaches, and it rubbed off on me a little bit as we started to co-teach a couple different classes together. I'm a painful introvert, so teaching is it's work, and I definitely enjoy it, but it can be, let's just say, not, on particular days, it might not be the thing that I feel the most like I want to do on particular strong introvert days. But when you get to the material and you start to have wonderful conversations with the students because you already had a planned set conversation point or questions that they can then relate and actually give you feedback from them and start bouncing off of. There's usually times when you're teaching classes that you need to realize you got to reel it back in a little bit because you've got them bouncing a little bit off topic. And actually, one of my students reminded me just the other day, it was a game I used to play in class after sitting down and breaking material up into digestible chunks where you sit on something for like 15 minutes and you lecture about this and then maybe ask some questions. When you start to stray off, I always tell them there's a game I would play that was 3 degrees of separation where they would try to get me as far off topic as possible. And within like 3 concepts or 3 talking points, we'd be back on microbiology or anatomy, physiology, or biotechnology. So it kind of turned the entire classroom into a little bit of a game. So as long as we could still cover the material in those 50 minutes or hour 20, yeah, we would get through it. But even if you're not covering the material, having engaged students is so much more valuable and useful of their time, and they'll remember at least that material that you covered in class than speaking at them for an hour 20 and them leaving wondering even what you said. One of the most interesting ones I remember is somehow we ended up talking about the Titanic, and I brought it back talking about, oh, that's on the bottom of the ocean, deep sea thermal vents. Hey, did you know that, you can isolate bacteria from there? And there we were, back on track.
Yep. So, Dr. Rohe, you also present at high schools and middle schools. Do you use a lot of those same techniques with the younger kids?
Yes. And so there's a few different things that I do. Sometimes I'm just sitting at a table at lunch trying to get them interested in going to college, specifically maybe Cecil College, and, learn some biotechnology while you're there. Other times I'm running workshops where I've got as young as middle school age students participating. One of them was girls in STEM. And there I was allowed to really just be a goofball. And as long as I was speaking something close to scientific, I had their attention. They were, I'm just going to say, laughing at me. I wouldn't necessarily say they were laughing with me because, middle school girls. But getting them interested in science all, again, has to come back to engagement. So you do have to be a little bit of a ham to get their interest, but then bring it all back in and realize that we're talking about biotechnology. We are playing with candy and popcorn, and we're isolating the pigment out of candy, but the techniques that you're using to separate the dyes in gel electrophoresis, it's all great. So essentially it's just, again, meeting the students where they're at. When I would talk about, we're talking about genetics, karyotyping, and things like that, I would basically say, thanks to incest, we've got my daughter. You can hear the breath leave the room, right? Exactly. Right? You're like, well, okay, so no, here in Delaware, we have a very lovely, a wonderful children's hospital. And the myth is that children's hospital, the A.I. DuPont and the Moores Christian Hospital, was initially started to help the offspring of the individuals that decided to reproduce with their cousins to keep the money in the family. And so it led to a couple decades or a century or so, we've got one of the premier children's hospitals there. And my daughter, born with Down syndrome, also has the cardiac complications. And at about 4 months old, she had to go in and have basically her heart constructed for her, all that because of bringing the history of everything and then talk about it. And then by the end of it, we're back to genetics and anatomy and physiology. And so it's just interesting ways of kind of throw some darts against the board and then track your way back to what you wanted to talk about. Mm-hmm. And yeah, you'll grab a class real quick with a comment like that. So yeah.
Yeah, you grabbed us, that's for sure. But I was here for that history lesson.
Yeah, you could pull them all in from kind of random points as long as you know your start point, that is the interesting tale, and how you bring it back around to it. So while it is predetermined, I sometimes just don't have that planned for the conversation for the day, but those times when I feel like I'm talking to a brick wall, yeah, throw some of those out there.
Mm-hmm.
Do you have any of your own, Dr. Cooper?
Of course. And that's what I'm known for.
When did you fall off the table in the front of class?
Yeah.
You were standing up, modeling something.
Yeah, I was standing up trying to model, I think I was trying to model an antibody, the Y shape, and I was using my hands. And then I was saying how some antibodies, they can lean like this. And the table had a weak leg. And when I did like this, it went, and I screamed, and my feet went up in the air, my toe shoes, and students just sat there and looked. And then I jumped up and said, I'm okay. And they bust out laughing again.
They will never forget that, though. They will never forget the shape of an antibody again.
Nope, nope. Because even on the exam, they say, "I remember this when you fail." So, teaching for me can be an extra because a lot of times I run around the classroom. I get students up. I use them as model. I try to use everything in the classroom I can to make learning engaging.
There's something that you said kind of earlier on. It was a sneak peek on future trends in microbiology education. Can you tell us a little bit more about that and how you're preparing students for a new world that might involve things like artificial intelligence?
One of the things in terms of microbiology that is not in my textbook now, but I'm gonna wait till after peer review, and then when we launch it nationally, I'm gonna add a section on it, and that is the microbiome of various anatomical sites. Right? We even got a microbiome in our mouth, so there's this big phobia of germs. But we have learned so much how we really need bacteria in our gut, in our mouth, in our vagina, for those of us who have it. Okay, on our skin, and a lot of that has recently come to light due to the advent of proteomics, biometrics, those type of things that been instructed with biotechnology. So what students are starting to learn, we even know that having a certain type of bacteria, which I want to get, can help you lose weight. It can fight cancer. And the way I tell you the cancer story, because this one is easy. So in let me look at what chapter, chapter on metabolism. That's chapter 4. I try to bring all that into bed. That's where we are going now in the subject of micro. Now, in terms of how we educate it and how we integrate AI technology, Dr. Rohe.
So the chapter I deal with really introduces biotechnology. And so the microorganisms that we use in the biotechnology world, we use bacteria as a tool. We use it to express genes that we can then quickly isolate. Now they might be from pretty much anything. Personally, I have put human genes into bacteria, chicken genes into bacteria. University of Delaware, the blue hens. There's a avian interest in this field. There was at the time. Microorganisms replicate much more quickly, and they are, for more or less, you can kind of say that they are simpler. They are very well understood, and so it works as a really good model for use in research. But not only that, the other side is you could use viruses. We do the same thing with those. We use them for delivery of genes and do things like gene therapy or treatment for you have to use viruses to treat stem cells isolated from humans, so not embryonic stem cell usage. These are from consenting adults decide to give off some stem cells, and then you can reprogram them by giving them certain sets of genes, and you can decide to do that with a delivery done by viruses. You can make cells pretty much do whatever you like through the use of these viruses and bacteria pretty much as your tools, like hammers and saws and screwdrivers, or use them all the way up as models to mimic human states. And so that whole idea is embedded in biotechnology. And then what most the interest is in my field in biotechnology, it's the industry that's around us is usually biopharmaceuticals. So they're then either directly using viruses, or you're trying to target viruses with your biopharmaceuticals, or pathogenic bacteria, the ones that cause disease, with the techniques that you're using and doing, or the product that you're trying to make, or you're using them to make a therapy to help individuals with cancer and leukemia. One of the major things right now is CAR T cell treatment for gene therapy and like gene editing. And without the help of a lot of bacteria, microorganism mechanisms, the Caspase-9 CRISPR gene editing system is isolated out of microorganisms as well. So it's a wide open field that we're utilizing to help ourselves And so the idea of biomanufacturing, just like Dr. Cooper highlighted, was hitting on, was that my program actually, we kind of have to span the gamut because we have limited time in about 2 years worth of teaching and education, is that we can use microorganisms to make things for us. We've known this. We've done this for quite some time. Back in history, we were using it to make bread and yogurt and brew beer and wine and all the things that we all love to enjoy. But now we also need to take that focus and twist a little bit and use it for advanced manufacturing purposes and make antibodies and therapies and treatments. And the materials that come out of biomanufacturing, getting live cells to make the things that you want, can include enzymatic cleaners that you put into detergents to help get that wine stain out of your shirt. So it's a wide open field, and trying to teach students that is a path that you can go into. Interestingly, not the University of Delaware. They've got a 4-year program, and most of them go in there knowing what they want to do. If you can try and convince any of the pre-med students to go into research science, it's a win. I consider that to be a win for us. But at the community 2-year college level, sometimes you're just showing students that, yes, there is a career in science. It's not just an interest while you're in college, and then you go off to go work a business job or something like that. You can earn a very decent living in science without having to have a doctorate and be the next big thinker pushing for a Nobel Prize. You could live happily as a laboratory manager, and with these techniques that we teach you, advance science a little bit. And a lot of them are actually students that want to be in the medical field, and they know they want to help people, but they don't want to go through nursing programs or med school. And so introduce them to the pharmacology side or the therapeutic side of things, and you're helping people. Your job is very rewarding, possibly financially, but also a major key component is that your job betters society. And so in the health field, that's definitely a worthy endeavor. So advanced teaching techniques to do advanced manufacturing techniques and help individuals kind of along the line is a great thing to do, and I'm happy to be doing it.
One of the last questions that I had was actually something that you mentioned, Dr. Cooper, about one of the other classes you teach about biology, microbiology, and race.
Race and health.
Race and health, yes. I was wondering if you could elaborate on that a little bit for our audience.
Yeah, sure. So like I said, I have a joint appointment in Africana Studies, and this was born out of the fact that I was doing a lot of community education in the underserved community, particularly with African Americans, where they deal with a higher burden of certain diseases such as HIV. I actually volunteer for a state-recognized HIV center called Beautiful Gate Outreach Center, where we do counseling and testing. There's a lot of misinformation in the African American community about things like Ebola and HIV. So that class is teaching me some things about society that I didn't know because I'm not a sociologist. I have one rule, and I said, no, the reason why we can't talk about race is because everybody gets upset, including this guy here, and we always make the wrong assumption. So I said, in this class, this is open for whites, Latino, Black, Native American, all to talk about this, because this is race and health. So we're going to have to talk about it. And we can't forget the past, because as a result of the past, some of us are suffering the consequence of it. But we could change. Change. But you can't treat a disease if it's undiagnosed. So society the same way. You're not slave anymore. Okay, we're not in Jim Crow anymore, but there's a long-lasting effect. And that's one of the projects I want to work on, is showing people the long effect of that, and how that is still impacting groups of people today. We even see that with the Nazi Jews, how certain time genetic things have gotten clustered. That's what one of my friends, Dr. Nick Trumpeter, give a lecture on. So this class allowed me to integrate sociology and biology. And it's a challenge, but I'm not an expert in sociology. So but I like doing new things and putting myself out there. So I make plenty of mistakes. I say some things off the cuff, and some of the sociology professors correct me. Some of my sociology students will correct me, and I appreciate it.
That sounds like a really great class. And it's true, though, that we don't like to talk about things that make us uncomfortable, but we have to talk about the things because we don't like to think about things that are upsetting. And it is upsetting, but obviously those conversations need to be had. So,
Well, I mean, Cooper, not even necessarily to that instance, but when we talk, we used to both co-teach a cancer biology course, and we both have some life stories in cancer biology. I lost my mother to it. Coop, you lost your father, and maybe even some other family members. Those presentations by the guest speakers in the cancer biology class, they were emotionally charged. The
Yes.
people, all of us, were crying sometimes by the end of it. And if you want to have students engaged, real life
yeah.
is the way to do it. And inviting guest speakers with firsthand experience in these things. Uh,
I like to use both Ben and I like using emotion and real story to bring home a point because we are emotional human beings, and that helps students remember too.
Mm-hmm. It's a very sociological approach to microbiology.
Yep,
Yeah.
yep. And I even have one of my questions on my exam. I put in things about anti-vaxxers, and I tell the students now, yeah, anti-vaxxers aggravate me, but I said you look at it from their viewpoint. They don't understand the way you do. So explain to an anti-vaxxer in layman's term, how does the COVID vaccine work? That was on my biology exam, and I left it open. I say, but I get this, and I say, best use layman term, use real life examples, use a diagram. Don't just write a whole bunch of words on a paper. Make it easy for them to see.
And it prepares them to have live conversations in the real world with anti-vaxxers.
I have students as well too, and basically some of my classes I teach, even from like anatomy and physiology down to the biotechnology as well, is that they have to remember that they're leaving college as an ambassador to science and try to find ways to express scientific notions and the good of science out to the general public where and when you can, and kind of like how to not necessarily just condescend and condone and negate and block people off and gatekeep, but to just bring them in with you. Sit down, have a conversation, and see if you can, change minds for the better, hopefully on occasion.
Yeah.
Exactly.
So, the last little segment we do on all of our podcast episodes is called You're Wrong. Not you, but maybe Michelle, maybe me, maybe our listeners. And this is your time to sort of set the record straight for some misconception in the world of microbiology. What do you want all of us to know that we're probably wrong about?
Well, I'll start with I want to start with the COVID vaccines. That goes in good with my and I know Ben doesn't like, that's one of the subjects Ben doesn't like is immunology because he never had it. So
I've had it. I never taught it. So you really learn something when you have to teach it. That's something I haven't had to teach yet. So
yeah. So as we're going through the pandemic, and I've heard this across a university with students taking it for the first time, but definitely out in the community and even in my circle of friends outside the university. Most of my friends outside the university never went to college. Okay, so they just don't understand the thinking process and the citation of literature and evidence, particularly when it comes to clinical trials. So here's from Dr. Cooper to everybody who does not believe the vaccine works. We know the vaccine worked because we do this thing called clinical trials, where these are tests done in people, not animals. I am and Ben, we are basic researchers, so we use cells and animals. Once it get past that, then it goes into this stage called clinical trial. And there are 4 phases of the clinical trial. Phase 1, you are only testing for toxicity. It doesn't even matter what the disease is. If the drug is too toxic, they're not going to use it. But all drugs going to have side effects. So vaccine going to have side effects. Particularly, they're giving you a part of a virus, in this case, an RNA genome that makes it part of a viral protein that's foreign and is going to activate your immune system. That thing called fever, that's your immune system. The body aches, that's your immune system. So it's not about the fact whether it doesn't have side effects. It's can they be, as my friend and colleague, well, not my friend, but my colleague, I wish he was, Dr. Fauci would say, can they be mitigated? Can they be managed? Okay, once you get past that, you go into phase 2. And that's where you look at the vaccine effect on the actual virus. And now, what do we do in a vaccine trial? Well, we can't give somebody COVID. That's illegal. So what they do, they have a group of people over here, they get the vaccine, and they have a group of people over here that don't get the vaccine. And then they see how many of these people get COVID and don't. And what they show with this trial, and you can go to clinicaltrial.gov and look this up. It's written in technical terms. That's where Ben and I come in.
Yeah.
Okay. But you can go look it up. And so then the next thing, so once we see that, now they get to the gold standard of clinical trial, where it's randomized and double blind. And this is to avoid bias. I don't want to go into the randomization of double blind. Basically, the doctor know what's being given and the patient know what they're getting. Okay. And then they make sure when they say randomized, every patient, regardless of their condition or comorbidity, have an equal chance of being in each arm. You don't want to put the bad patient in the trial where they don't have the vaccine, because that can make it sound like the vaccine didn't work and the patient died, but they had advanced diabetes. So you want to have equal chance of putting an advanced diabetic patient in the control and the experimental if they use a diabetic patient. And they tested about 35,000 people. And that's how they determined how effective it was. That with the Moderna, I think it was 95, 92, I might be off a little bit, but it was because the flu vaccine is not that effective. It is effective, but it's not 90-something%. So that's how they know it worked. Now, it was emergency approved because why? We're in a global pandemic. This is a virus that you walk in the grocery store, get it, and you dead. This isn't a virus like HIV in the 80s where you go and you use drugs or have sex unprotected and you got it. This is a virus, you just going into the grocery store, you going to the beautician, you got on the bus and it's in the air and you get it.
Yeah.
So when we're in a situation like that and people are dying so fast, the hospital can't keep up, the morgue can't keep up, we got to take drastic emergency action. And Dr. Fauci and our public health team did the right thing. So people, let me tell you, the vaccine work. So if you don't want to take it, you just don't want to take it. But you can't say you don't want to take it, it doesn't work. And then the last thing, well, we don't know what it could do later. Well, we know what COVID could do now. So if you get COVID, there's no later for you. And one of the doctors I met said there are young people, although they survived it pretty well, but they're experiencing more symptoms of long COVID, severe symptoms of long COVID. So the later, we got to get there first. But we do have a good idea because some of the things that we use in the vaccine, we've been using for years. The vaccine work, and that's based on science, not politics. Ben?
Overall, I'll say Dr. Cooper just went full teaching. He went full sermon on there, using his large classroom voice. I've heard that many times, and it'll rock a room. There's a lot. Tough to pick one, and maybe even just to stick it to microbiology. But because it is like the main focus, it's kind of like the one truth that is there in life and biology. I'm going to be the one to say it is evolution. General public understanding of what a scientific theory versus hypothesis is, and that basically all wrapped up that we call it the theory of evolution. A lot of people think that it's still kind of like up for debate or it's wrong, but there is just so much evidence for it. And like the way that it boils down to microbiology and the conversation I'm usually having around it is the idea that, and kind of butting up against what Dr. Cooper said, was, why do you have vaccines for some things and not vaccines for other things? Well, one is a question of usually like those side effects to be mitigated from the COVID vaccine, is it a disease brought on by a virus that is really worth the cost and expense and research dollars and to invest in? Do we really need to have a vaccine for a cold? A cold is a couple bad days with some sniffles and some sneezing, and you get to stay home and have some soup and watch some daytime TV. Okay, binge something off of Netflix. It's not that bad. A headache, and we have medications that can treat the symptoms, and humans with immune systems that are fully functional, you're pretty well off just a few days later. The flu is less so. So a lot of the arguments balance between, COVID and the flu is, well, why do we have flus and why can you still get sick? Or can you still get the flu after you've had the vaccine? And just generally the idea that the flu evolves, and epidemiologists are trying to get their best guess at which one is going to come to, being here, which one's going to come to the US. And I think they usually follow the model of what's happening in Australia.
Or China.
It comes from the West, even though China is like technically the Far East, the borderline there. But yeah, to us, it's what's happening to the west of us. And that has a tendency to kind of flow in this way. And even though we've got the best models, we're hypothesizing that this is the flu that's going to come, and sometimes you guess wrong. So while the general population is benefiting from the vaccine for the flu for this season, that is hitting most of us, and we're all mostly good. You've got that friend or that one person you heard stories about, the person that got the vaccine and still got sick. They had a different flu. You have to start explaining how random mutations lead to variations in the viruses and all of that. And a lot of people take that uncertainty to think that science doesn't work, vaccine, healthcare, it's all a big scam. And again, basically, it's not. It's just life. It's all of us living in the world of evolution that leads to wonderful things that led to us, but also some things that we can't entirely predict because it's random. And to go along with the COVID vaccine as well, like what about all these strains that pop up that you now need to get revaccinated for? Yeah, things changed. They changed on us a little bit, and now there's a new coat protein and a new spike protein that your body hasn't recognized, and now you've got this round of COVID, but you're safe if that one shows back up again. So,
right.
Just again, general understanding of evolution and how it is kind of in the big picture, usually the answer to most of what the big questions are. Yeah.
The virus evolved very fast.
Yeah.
Right.
Because they're small.
Right.
Small genomes, a couple changes to it, and very, very effective ways to avoid the immune system.
The theme of today's conversation, in my opinion, is passion. Dr. Rohe and Dr. Cooper's passion for microbiology and education brought them together to develop their textbook. That passion persists in their teaching and how they engage with students. It's demonstrated in their emotional and vulnerable storytelling during classes, which leaves a memorable and lasting impact on their students. And their passion for education and their own continued learning is evident in their work to develop new classes and programs that will shape future generations of students. Thanks for tuning in to Can I Get a Retake, a podcast by Great River Learning. If you liked the episode, show your support by subscribing, sharing, and leaving a review on your favorite podcast platform. For detailed show notes and transcripts, visit greatriverlearning.com.
Can I Get a Retake is brought to you by hosts Michaela Albee and Michelle Manneman, with editing by Maggie Christensen. Artwork for the podcast is crafted by myself, and our intro music is courtesy of Comma Media. We'll be back soon with another captivating chat with a top GRL innovator.